Okay, so you got a new book today. You write your name in Sharpie on the front cover. On the front cover. So if I find it, I can get it back to you. Now, we are not done with the Volume 1 math book, but we're moving on to Volume 2. We have actually already started Chapter 7. You guys just didn't know it was Chapter 7. Okay? Chapter 7 is order of operations and expressions. Chapter 8, 9, and I think 10 are on fractions. Rory, you with me? Okay. We're going to do fractions, and then we're going to go back to Book 1 and do decimals, which are the last two chapters in Book 1. Okay. So I collected your Unit 1 or your Volume 1 books so they don't disappear before we need them again. Okay. Put the books closed. Your name should be on the front. We'll get in them in just a second. Okay. You also have 3 different papers that I just gave you. I want you to lay them out on your desk and write your name at the top of each one of them. Drake, if you separate that, that is 3 separate pieces of paper it should be. Okay, put your name at the top of each one. One of them says 5 Math RTI. One of them just has some division problems, and one of them is this week's weekly worksheet. We're going to be talking about all 3 of those before we start on the lesson. So we're first going to focus on the one that says 5 Math RTI. Okay, it kind of gives you a little calendar up there at the top, and it kind of explains what you're going to be doing this week in RTI. For today, which is Monday, it says assign groups. I'm going to do that in just a second. And begin long division coloring activity. That is the long division worksheet in front of you. Okay, it has 16 long division problems. What do you notice about those long division problems? What do you notice about them, Zach?
They're all division.
Okay, they are all long division. Caleb? Okay, the numbers are larger, the dividends are larger than we're used to. Dylan?
They keep on getting harder.
Okay, the divisors get, okay, the problems in general get harder, but also, what do you notice about the divisors? Audrey?
I was going to say something else.
Caleb? Rory? No one notices anything about those divisors? Noel?
They keep getting bigger.
Yeah, they're not easy divisors. They're double-digit divisors besides the very first one. Easton T, do you know your multiples of 41? No. So what are you guys going to have to do before you even start? You're going to have to make a list of multiples. Now, these are hard problems. My suggestion, use your group members, okay? Every group member should make a list, because if we goof up, where do we usually goof up? On the goofy stuff, little easy stuff. If we're using repeated addition, maybe we take 1 plus 1 plus 1 and get 2. So my suggestion before you start doing long division, everyone in the group make a list. Compare your lists. Make sure you all agree on the multiples of 41 before you start doing long division. Okay? Let's say number 1. Let's say we got the answer of 229. I don't know what the answer is, but let's just pretend the answer is 229 to box 1. Flip that paper to the back. You should be looking at a dinosaur. Look for the number 229. 229. Does anybody see the number? Easton has his finger on it. It's just to the right of the dinosaur's head. Everybody put your finger where it says 229. What color does it say?
Pink.
Pink. What do you think we write next to where it says number? We'll write number 1. If that was the answer to problem 1, we would put a 1 in that box. And then on the dinosaur, we would color all of the number 1s pink. Okay, does that make sense?
Yeah.
How can this side help you? How can this side help you? Emma? Yeah, if you get an answer and it's not on that back side, that means you need to go back and fix your mistake. Doesn't mean go back and just change the answer. No, these are hard problems. That's why I'm giving you groups, okay? Use each other. If someone has the right answer, help figure out where the other people messed up. Does it mean tell them to change a 6 to a 7? No, okay? Help them get to the answer. Don't just give them the answer. That does not help. So this dino coloring activity is what you will be working on today and Wednesday in RTI, okay? Because we don't have Chromebooks. Easton.
So what about these number signs right here?
That's where we put, like, if 229 was the answer to number 1 on this side, we would put a number 1 under 229. So that tells us that all of our number 1s are going to be colored pink. Does that make sense? Yeah. Okay, Kylie.
Do we have to use crayons?
Yes, or colored pencils, no markers. Okay? So Monday and Wednesday, if we need to overflow this into next week, we will. We'll just kind of play it by ear. You're going to have to stay focused during RTI to even get close to finishing. Okay? So that's Monday, Wednesday. Go back to the other sheet where it kind of has our schedule at the top. On Tuesday, it says digital multiplication and division review. If you flip that packet, it says show work on page 2. If you just flip it to page 2, okay, I just flipped it the whole paper over the page I'm looking at. It gives me directions for that activity. It says multi-digit multiplication and division review, digital activity. If it is a digital activity, what does that mean? It's going to be on a Chromebook. So now I'm going to read the directions for that. It says one person from the group will log into Google Classroom and go to the classwork tab at the top under RTI, find the assignment titled Multiplication and Division Review. Open it to find the problems. Each group member will copy down and work each problem. Students should discuss/help each other as needed. Show all work, and when the group is finished, the person with the computer will turn in the digital assignment, and all students will turn in the work packet for a grade. Okay, this packet will have your work for both activities. Okay, for the dinosaur coloring one and the digital. I put it all together to where you didn't have a whole bunch of papers that you had to turn in. Okay? This is what I'm grading. I'm going to collect also. The dinosaur should be colored. On the front side where there's the division problems, you can just put answers. Because are you going to fit your work in those tiny boxes? No, all of your work will be on the packet that says 5 Math RTI at the top. Okay? And that one is a mix of multiplication and division. Okay. So flip your RTI paper to the back real quick. I am going to give you your groups very, very quickly. I want you to write the names of the other group members and what room you're in. Aiden, what are you looking for? It's back there. See it on my shelf on top of my fridge? Right there. Okay. So flip your paper over the back. When you hear your name, write down your group members. Okay? Tyson, you are with Augie. So write down Augie and Sophia. So Sophia, write down Tyson and Augie. Brennan, Callie, and Elise. Brennan, Callie, Elise. Brennan, Callie, Elise. Waylon, Emma Kay, and Caleb. So Caleb, Waylon, Emma Kay. Caleb. Write down Emma Kay and Waylon. Next group, Mila, Noel, Bryson, Jackson. So you guys have a group of 4. Noel, write those down. Bryson, Noel, Mila, Jackson. Drake, you're with Mason and Ava. Next group, from this class, Arabella, she's absent. Grayson's absent. And then Braylon and Gabe. So it'll just be Braylon and Gabe today. Next group, Aubrey N. Where you at? Aubrey, you are with Emma E. and Aiden. Emma E. Sorry. Everybody up to that group is in my room. Aubrey, you're in Miss Beer's room. And these will probably switch, but for now. So So Aubrey Ann, you're with Aiden and Emma E. Next group, Cam, Kylie, and Aubrey E. Cam, Kylie, Aubrey E. Cam, Kylie, Aubrey E. Miss Beer's room. Next group, Emma Lapp, Rory, and Addie B. And Addie's absent today. So it'll just be you two. Next group, Dylan, Madison, Clara, and Fisher. Dylan, Madison, Clara, Fisher. You guys are in Miss Beer's room. Next group, Easton T. You're with Lexi and Hutley. Lexi and Hutley. Miss Beer's room. Next group, we have a lot absent, so the only ones that are here, Audrey and Colby. Might have to give you some group members for the day. Okay? Okay. And you won't be in there for RTI, right? Okay. Okay, questions about RTI? Okay, next thing I want you to do, open up your math binder, or get out your math binder. So actually, you won't need these. I'll still have you put it in there. Maybe Miss Hamill can she work on it. Okay, in your math binder, I'm going to hold up Zach's. See how everybody's looking at the front? Flip it to where you're looking at the back. Open it. I'm going to have you put this in the very, very back. Your RTI, your two RTI papers in the very, very back. So for RTI today and this whole week, what will you need? Your math binder. So put these in the very back of your math binder. Pop it shut. And then flip to where you have weekly worksheets in IXL. What's the third piece of paper I gave you? Weekly worksheets in IXL. So put that in where it belongs, and we're going to take one little extra note on it before we move on to the lesson today. Luckily, today's lesson's short. We had lots of little housekeeping things we had to do first. So on our weekly worksheet, there's no new skills. Notice I've been staying with the same skills because I feel like we still need some practice with them. We have order of operations, multiplication, long division, converting mixed to improper, improper to mixed, and a coordinate plane. On the coordinate plane, I gave you one hint. I said, remember x comma y. What else do I need to remember when I am graphing those? I want everybody to write this in this box. Audrey, what else do I need to remember? Colby, open up your binder.
The 2 goes with the x, like for the first one, the 2 goes with the
Okay, they're in the order x comma y, yes, but what else do I have to remember when I'm graphing them, Dylan?
x is right and y is up.
Yeah, it's telling me, the first number is telling me to move to the right, and the second number is telling me to move up. Okay, besides that, I think you guys will be good to go on that. Okay, once you have that little note added to your weekly worksheet, close your binder, open your book to page 481, which sounds like it would be at the back of the book, but it's the very front of the book because it picks up where our last book left off. I think 481. Here's your book. You were opening Wordly Wise. So we are actually doing chapter 7, okay? We've already started chapter 7. Chapter 7, lesson 2 is order of operations. We've already spent a whole week or more on order of operations. But we're going to back up just a little bit today. I think it's page 481. Is that correct?
This is what it's on 481.
Yes, 481. But again, it's at the very, very front. It's the very first lesson in this second book. Let's see if it's going to kick me out here. So we're going to use bar diagrams to write expressions. While I'm waiting for this to load, Who can remind me what is the difference between an expression and an equation? Expression and equation. What is the difference between an expression and an equation, Rory?
An expression is like a problem that's like two numbers like 5 plus 5.
Okay, you're right. That is an expression. You gave me an example. Who can tell me the definition of an expression or an equation? There's one main difference. What 3 letters does equation start with? What, Callie?
Equal.
Well, it doesn't start with equal, but it sounds like equal. That can help us know the difference between an equation and an expression. Aubrey? Not add. Dylan?
It's like when the equation is a math problem that you actually do, and expression is just like a.
No, we can actually do expressions and equations. Good guess. Madison?
Equations are like 2 plus 3 equals something, and expressions are just 2 plus 3.
Okay, so she said 2 plus 3 is an expression, 2 plus 3 equals something is an equation. I agree. So what is the difference between an equation and an expression? Kylie?
An equation has an equal sign, and then an expression doesn't.
An equation has an equal sign, an expression does not. Order of operation problems. Are they equations or are they expressions? They're expressions because they don't have an equal sign. But Dylan, can we still do them? Yes, so we can evaluate, or what you guys call solve, all of them. But really, mathematically, we can only solve equations. We can simplify expressions. But in your head right now, that all means the same thing. So we're going to take lots of notes in the book today. So anything I put on the board, you will put in your book. And what we're doing today is we are using these bar diagrams to come up with expressions. We're coming up with 2 different expressions for the same bar diagram. And then you'll be doing the same for homework tonight. If I can ever get there. Okay, the first one, let's look at the top first. It says a numerical expression such as 8 plus 7 is a combination of numbers and at least one operation. You can find the value or evaluate the numerical expression by completing the operation. Okay, so numerical expression is just a fancy word for saying a math problem with only numbers and no equal sign. So like order of operation problems are numerical expressions. Okay, so at the bottom down here, our first example says Gregory and his family went hiking over the weekend. On Saturday, they hiked 5 miles. On Sunday, they hiked 5 miles. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total numbers of miles hiked. You guys used to use these to write addition problems, subtraction problems, multiplication problems, division problems. Step 1 says use the bar diagram to write an addition expression. What math problem, what addition problem is that bar diagram showing? Audrey? Okay, but what math problem specifically? 5 plus 5. Do you guys agree? Yeah, because it's saying if you take these 5 miles and add them to those 5 miles, you would have our total miles. Now, on the next one, it says evaluate the expression. We're going to mark out that equal sign in that line. How do we evaluate expressions? Do we work horizontally to the side? Where do we work them? What should our numerical expressions, I'm using new words, what should our numerical expressions look like when I'm done? Emma? You guys worked a whole lot of numerical expressions right before break. They were just a lot longer than these. Order of operation problems. What does our work look like? Kylie? Upside down triangle. We're working on the same, even these short ones. So we're rewriting our expression What's 5 plus 5?
10.
10. We're going to write the answer under it so we have our upside down triangle there. It's just a very basic upside down triangle. Colby, did you get all that? Okay, the next one says use the bar diagram to write a multiplication expression. So something I want to make sure you know, bar diagrams always show addition. It's always an addition sentence. But how can I turn it in, or why can I turn it into a multiplication problem? Mila?
Because you're going to have an equal sign for your answer, and you're not going to have an upside down triangle.
Nope, I'm still going to have an upside down triangle. I'm still going to solve an expression or simplify an expression. But how can I turn the math problem 5 plus 5 into a multiplication problem? Aubrey? Why can I do 2 times 5?
Because if you do 2 times 5, that means if everything that with addition.
5 plus 5 is a repeated addition problem. Anytime we have repeated addition, we could flip it to a multiplication problem. So down here, we're going to evaluate this expression. Again, we're going to mark off that equal sign and work it properly. What is 2 times 5? 10. Did we get the same answer both times? Why should we get the same answer no matter how I work the problem? Audrey?
Because if you get, like, for the first one, you get 10, and then for the second one, you get 12, you'll be wrong.
Yeah, if you're working the same problem 2 different ways, you should still get the same answer if you do it correctly. So we agree they hiked a total of 10 miles. Okay, copy that down and then flip to the next page. This one says Mrs. Yearling has 2 groups of 5 students and 2 groups of 4 students. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of students. The first one says use the bar diagram to write an expression using only addition. I want you to box in where it says only addition. And they help us get started, but remember, a bar diagram always shows addition. So to come up with your addition sentence, really you just add across. So this one would be 5 plus what?
5.
5 plus 4 plus 4. Then it says evaluate the expression. Do we have enough room right there to evaluate this properly? Nope, so we're going to mark that off. Then we're going to come right up here and evaluate it. Now, you guys aren't going to like this because I'm going to make you do it the proper way without skipping steps. When it's all addition, we could skip some steps and still get lucky. But when we throw in subtraction, we can't skip steps. So I don't want you guys to get in that bad habit. If I have addition and subtraction, what is my rule? What is my rule? Brennan, what's my rule if I only have addition and subtraction in my math problem?
Rule is
Work it how?
left to right.
From left to right. So what am I going to underline first, Brennan?
5 is 5.
Okay, underline 5 plus 5. We know that's 10. Copy everything else down. Colby, what am I going to do next? Nope. We go left to right. There you go. 10 plus 4 is what? 14. I'm going to copy down my last plus 4. Zach, what's 14 plus 4? 18. Okay, number 2 says use the bar diagram to write an expression using multiplication and addition. And remember, when we're changing addition into multiplication, what am I looking for? Cam, what am I looking for when I'm changing addition problems into multiplication problems? Nope, there won't be parentheses. I'm going to have to put those parentheses in a second. How do I know what I can change into? How did we know on that last problem we could do 2 times 5? Because there was what, Mila?
Because there was a multiply section and it's the same problem.
Well, it asked me for multiplication, but how did I know that I could do that, Noelle?
There were 2 5s.
Repeated addition. Okay, if you have repeated addition, you can flip it into multiplication. So who thinks they know what that next line's going to be? Madison?
2 times 5 plus 4 times
2 times 5
5
plus.
2 times 4.
Because we have 2 5s and we have 2 4s. Okay, same thing. Let's mark off that next line. We're going to come out here and do it right, and we need a little more space. I'm going to get too tight there. Usually these problems we get to our answer quicker. Drake, what am I going to do first on this problem?
Do 2 times 5.
Okay, why do I do that first?
Because it's in parentheses and plus it's on the left.
Good job. It's in parentheses and it's the one in parentheses on the left. Callie, what am I going to do next?
2 times 4.
Good job. What's 2 times 4?
8.
8. Copy everything else down. I know I'm getting kind of down in my print there. 10 plus 8? 18. Did we get the same answer?
Yeah.
Why should I get the same answer? Audrey?
Because they should, if
Because I'm working the same problem. Okay, if I'm working the same problem 2 different ways, I should get the same answer. I want you to look over at the next page. We're skipping that bottom. Let's do number 4. Number 4 says Bailey's soccer team had snacks after the game that included 12 granola bars, 12 mini muffins, and 14 bananas. Use the bar diagram to write and evaluate 2 numerical expressions to represent the total number of snacks after the soccer game. The first one, notice this one doesn't give me any hints. The first one wants me to use only addition. Who thinks they can give me an only addition expression for that bar diagram? Colby, go ahead. 12 plus 12 plus 14. Okay, and it says write and evaluate. What does that mean? Does it just want me to write it? Yeah, it means it wants me to do some math. We're going to do this out to the side on all of them. Zach, what am I going to do first? To evaluate this. $12 plus 12 plus 14. What's my first math problem I need to do?
12 plus 12.
Yep, because it's on the left. What's 12 plus 12? 24. Drake, what do I do next?
24 plus 14.
Okay, you getting all this down? Okay, what is 24 plus 14, Easton? T? 38. The second one says write and evaluate an expression using multiplication and addition. Remember, if there's multiplication, I look for my repeated addition. Cam, do I have any repeated addition here? Okay, so what can I change into a multiplication problem? Yeah, I have 2 12s, so I can do 12 times 2. What do I have to put around that 12 times 2 that says, hey, you have to do this first? Callie? Parentheses. Once we take our 12 times 2, then what are we going to do, Mila? Add 14. So we wrote it. Now what do we have to do? Evaluate it. And again, you'll always have to come out to the side on these. They just don't give us enough room. In this expression, Kylie, what am I going to do first?
You have to do 12 times 14. 24.
12 times what?
2.
2 is what?
24.
There we go, 24. And again, we have the same math problem. What's 24 plus 14? 38. Did we get the same answer? Why did we get the same answer? Mila?
Because you're doing the same problem.
We work the same problem twice, so that one's 38. Okay, I want you guys to do number 5 on the next page. Flip, I want you guys to try number 5 on your own. Try number 5 on your own. Who can give me the addition sentence that's shown? Ty, can you give it to me? What's my addition sentence for number 5?
6 plus 5 plus 6 plus 6.
Okay, he did 6 plus 5 plus 6 plus 6. He went in order. Did anybody have something that they think is still correct, but it's not exactly the same as Tyson? Noelle?
6 plus 6 plus 6 plus 5.
Okay, so she grouped her 6s. 6 plus 6 plus 6 plus 5. That one works. You have something else?
5 plus 6 plus 6 plus 6.
5 plus 6 plus 6 plus 6 also works. She grouped them also. Okay? When you evaluated that, Dylan, what did you get? 23. Okay? So no matter which expression you came up with, when you evaluated it or found the answer to it, you should have gotten 23. Who has a multiplication and addition sentence? Brennan?
In parentheses, I did 3 times 6, then out of parentheses, I did plus 5.
Okay, so in parentheses, 3 times 6 plus 5. Okay, does somebody have something different? Because that one works. Kylie?
I had 6 plus 5 plus 6 times 2 in parentheses.
Okay, always group all of your multiples. Like if you have 3 6s, count them as 3 6s instead of 2 6s and then add another one later. Does that make sense?
Yeah.
Okay. Aubrey, what did you have for the multiplication? Did yours look like this?
Mine did 5 plus 6 times 3.
5 plus 6 times 3. Okay, those are probably about the only ones that work there. And Kylie, you still would have got the answer. It just wouldn't be the best way to set it up. Yeah. Do you see why? Okay. Now, on both of those problems, what would we do first, Easton T? On both of those problems, what would we do first?
You would go from left.
No. On these two problems, what would we do first? The parentheses. In both of them, the parentheses are 3 times 6. What's 3 times 6?
18.
18. What's 18 plus 5? Did we get the same answer? Yes, you should have had some work out here to the side on both of those. But both of them came up to, they saw 23 birds. Okay, we're going to start on the one at the bottom. I don't think we'll get through it. Which one doesn't belong? The bar diagram below can be represented by 3 of the 4 expressions underneath it. Find the value of each one. We're not going to have time for that's the piece we're going to cut out. Find the value of each expression. We could, we just won't have time to. And circle the one that does not represent the bar diagram. So let's look at this first one. We're trying to figure out which one doesn't work. So the first one says 5 plus 4 plus 5 plus 4 plus 5 plus 4. Does that one match the bar diagram, Cam? Okay, why?
Because it's the same number.
Yeah, they just pulled them directly down. They didn't switch the order or anything. They just added like a plus sign between all of those. So that one's a good. We'll put a smiley face above it. The next one says 3 times 5 plus 3 times 4. What do you think, Callie?
It's correct because you can do, there's 3 5s, and there's also 3.
Yeah, there's 3 5s and 3 4s. So we're agreeing that these two are the same. Let's go ahead and put a smiley face there. Let's go ahead and evaluate this one because it's quicker and easier. Mila, what would I do first in this problem?
You have to do 3
which is 15. I'm going to write plus 3 times 4. Rory, what would I do next?
You would do 3 times 4.
3 times 4 is what?
12.
12. So that would be 27. So I'm going to go ahead and write 27 here because I know those are the same. I'm going to cheat because of time. What about the next one? 3 plus 5 plus 3 plus 4. Caleb?
Does not belong because there's no 3 to add.
Yeah, there's no 3's in our bar diagram. If it's all addition, that means those numbers are in our bar diagram. So this is the one that doesn't belong. Let's go ahead and look at the last one real quick. 3 times 5 plus 4, the quantity 5 plus 4. And that one has to work because it tells us 3 of them work and 1 of them doesn't. And we know that one doesn't. This is kind of a weird one for us, but why does that work? Drake?
Because you take 5 plus 4 times 3 times.
Because there were 3 4s and 3 5s. That only works if it's the same. Yep, but there are 3 of each of those. Okay, listen carefully. Listen carefully. Don't close your book yet. Your homework is page 485 and 486. There's only 3 problems there. Okay, but for each one, you're writing 2 expressions and evaluating. And what do you have due on Friday? Weekly worksheet. Okay, so yep, your homework is page 485, 486, and then weekly worksheet is due Friday. Okay, you guys can go ahead and go. I will see you tomorrow.